Welcome back, everyone. In this video, we're going to look at 5 pro f-string techniques. Alright, first up, you built a custom class, maybe something to handle money. We've got a dunder init method and a dunder string method to format the output. Let's create an object. When you print it, Python calls the dunder string method. In this example, we're printing with 2 decimal places and the currency comes after our number. That's great and all, but what if you need a different format specification? Maybe sometimes you need more precision, like 3 decimal places, or maybe you want the currency information to come first. Let's try printing it now. That did not go well. You could write a bunch of methods, or you could use the dunder format method. F-strings have a secret protocol. When you add a format specifier, like .3f, the f-string doesn't format the object itself. Instead, it asks the object, hey, how do you want to be formatted with .3f? By calling dunder format with the format specifier. It's passed the format spec, which is everything after the colon in our f-string. In our logic, we check the format spec for a C. If there is no C in the spec, the else block executes and we print the currency after the number. Let's run the code now. We get our 3 decimal places and the currency comes after the number. But now we can create our own custom format spec. Let's use our C specifier to put the currency at the front and add a comma for thousands. Boom! How cool is that? By implementing dunder format, you give your objects their own formatting intelligence. You're not just pushing data into a string, you're creating objects that know exactly how they should be displayed in any context. Okay, so now your objects are smart, but what if the format itself needs to be dynamic? Imagine you're building a report table. You use a loop to print out each user's name and their city, separated by a pipe character to make the simple report. Now let's run that. What a mess. Our columns aren't aligned and our pipes are all over the place. Let's fix this. To make this work, the column widths need to adjust based on the longest piece of data. So let's determine the longest name in our data, as well as the longest city in our data. In the fix, we'll use nested f-strings. You can put an f-string inside the format specifier for another f-string. The inner f-string gets evaluated first, and the result is used as the format for the outer one. Check this out. See that? In the name format, the inner f-string, max name, becomes a number, and the outer f-string uses it for the width. Perfect alignment every time. Now, a quick warning. This is a superpower, and with great power comes the ability to write absolutely unreadable code. If you find yourself nesting more than one level deep, take a step back. This next technique, added in Python 3.8, is my absolute favorite. It'll change the way you debug forever. How many times have you written code like this? It's tedious and you have to type every variable name twice. Well, say goodbye to that. Get rid of the boilerplate variable name and just add an equal sign. And look at that. It prints the variable name, an equal sign, and the value automatically. This is self-documenting code. It's perfect for quick state checks and understanding complex calculations. You can even combine it with other formatters. Here it shows you the expression which it runs, as well as the result of the expression. This simple equal sign is probably the most impactful debugging feature added to Python syntax in years. Did you know you can put conditional logic directly in an f-string? Using Python's ternary operator, you can make your f-strings respond to your data on the fly. This is so much cleaner than a multi-line if-else block just to build one string. And it's not just for conditionals. You can embed almost any valid Python expression, like math operations, method calls, or function calls. F-strings are basically a mini templating engine. But just like with nesting, remember the golden rule, keep it simple. If your logic is getting complicated, calculate it in a variable before using the f-string. Our final technique is about being explicit. In Python, objects have 2 ways of representing themselves as a string. Dunder string, a clean, human-readable version used by print, and dunder repr, an unambiguous, developer-focused version. It often looks like the code you'd write to create the object. By default, f-strings use dunder string. Here we're printing out today's date, and we get the dunder string representation. But you can force them to use a different one with the conversion flag. Let's print the same variable, and this time add bang r, the conversion flag, to use dunder repr to the end. The bang r version gives you the developer-friendly, official representation. There's also a bang s, which explicitly calls dunder string. This is usually the default. This even works with our new favorite f-string technique, the equal sign. By default, the equal sign uses dunder repr, as we see here, but you can force it to use dunder string by adding the bang s to the end. Knowing the difference between dunder string and dunder repr and how to control it gives you total command over your output. F-strings are so much more than hello name. They're a deep, powerful part of modern Python that embodies the language philosophy of being batteries included. Check out this next video where you'll see another amazing superpower built right into Python. And be sure to subscribe for more deep dives into Python and software development. Thanks for watching, and remember to always begin secure.